Hi class, this is course 3, lesson 31, adding integers and collecting like terms. Okay, so addition with two integers, there is this chart that I would like you to put in your notes. To find the sum of addends with different signs, you subtract the absolute values of the addends and you take the sign of the addend with the greater absolute value. So when we are adding, we need to look for the absolute values when we have different signs, and we will practice that in just a minute. To find the sum of addends with the same sign, we're going to add the absolute values of the addends and take the sign of the addends. Okay, so first off, notice that when we are adding, okay, so this is all adding, we are finding the sum. When we're finding the sum, if they have different signs, then we're going to end up subtracting the absolute value. And if they have the same sign, we're going to end up adding the absolute values. Okay, so that's the difference there. So we're going to go to the next slide here and do 4 sample problems. The first one, -4 plus +5. Okay, so I am adding, and I notice that they have opposite or different signs. So that was the first one here. I need to subtract. So first I need to find the absolute value of each of these and write that down. So the absolute value of -4 is 4, and the absolute value of +5 is 5. And then I need to subtract these. So don't subtract 4 minus 5. Okay, take the value, the larger value, and subtract the smaller number from it. So the difference between the absolute values is 1. Now what is the sign of the larger number from the original problem? It was a +1, so our answer is going to be +1. I do not need to write the plus sign, because that's not how we write +1, but if you do write the plus sign, I wouldn't count it wrong. Okay, over on the right hand side, I have +4 plus -5. So again, we are adding, and they are different signs. So find the absolute value of each of these. So the absolute value of +4 is 4, and the absolute value of -5 is 5. And then subtract, put the larger number on top and subtract the smaller number from it. So when I subtract the absolute values, I get 1. And now I need to go up the number that I had put on top of my subtraction problem was the 5, and the 5 originally was negative, and so my answer, my difference is going to be, or my sum actually, is going to be -1. Down on the left we have -4 plus -5. Again, I am adding, and I am adding the same sign. So when they are the same, we're going to find the absolute value, and then we are going to add them. So 4 plus 5 is 9, but then I keep the signs that they both had, -9. Okay, on the bottom right hand side here we have a problem, -4 plus a +4, and if you look very closely at these two integers, they are opposites, and whenever you add opposites, your answer will be 0. Okay, collecting like terms, this can be an area that we struggle in, so pay attention and make sure that you ask plenty of questions. First, some vocabulary. Terms are expressions that include a positive or negative number and may include one or more variables. Okay, so I list some examples here. 3x squared, negative RS cubed, x, and negative 5 are all examples of terms. They include a positive or negative number, so there's a positive, a negative, a positive, and a negative. And they may include variables, but they don't need to, like the number negative 5. Okay, a coefficient, and we had this when we talked about scientific notation, but a coefficient is the number part of a term. So, some examples. 3 is the coefficient of 3x squared. Negative 1 is the coefficient of negative rs. And 1 is the coefficient of x. Now note that when the coefficient is 1, it isn't written. You see how there's no number 1 right there? But we definitely have 1x sitting there. So the coefficient is 1, but we don't write it. Okay, so if you end up with 1x left, do not write the 1. Okay, that's just not good form. A term without a variable is a constant, and in the list that we illustrated up at the top, negative 5 is a constant. Negative 5 is always worth negative 5. When we introduce the variable, then that value of the term will change, making that not a constant, but because there is no variable, it's always this value, so it's a constant. Okay, like terms, so we talked about terms, but like terms have the same variables, including the exponents, but they can be in any order. And so I've given you examples here of like terms and unlike terms. Like terms would be negative 4xy and yx. Okay, notice that these two terms both have the variable x and they have the variable y. It's okay that they're not in the same order. We can rewrite this as x, y. That would be commutative property that lets us rewrite that as xy. And then you can see that these match up. The coefficient of this term, xy, is a 1. The coefficient of this term is negative 4. Those coefficients do not have to be the same in order to have like terms. Another example would be 8x squared y and 3x squared y. Those are like terms. They both have an x squared and they both have a y. Unlike terms, 3xy and 4xy squared. They both have an x, but the powers on the y are different. There is a 2 here and a 1 here, making those unlike terms. Now, the lesson 31 said we are going to collect like terms. You may hear me reference that we are going to combine like terms. It's the same thing. When we collect or combine like terms, we add or subtract the coefficient, and we do not change the exponents. Okay, so we're going to do one example here. We are going to simplify by collecting like terms. The first thing that you need to do, or that I suggest you do anyway, is to identify what your like terms are. So I have this positive 8x term, and I have this negative 2x term. Those have the same variable. They both have an x. And remember that the term has a positive or negative number associated with it. So you take the sign of the term is included with the term. Okay, so this was a negative 2. And you might say, but isn't that a subtraction sign? And it is, but it goes with the term. This is the same thing as negative 2x. Okay, the other terms we can look at and see if they are like terms, and they are both constant terms. So we can rewrite this. You can do one of two things here. You can rewrite this using the commutative property, or you can just combine like terms. Okay, so what we're really doing, I will rewrite it just so you can see. We really have 8x minus 2x plus 6 plus 5. Okay, so I just moved the like terms together. And then what you need to do is evaluate these separately, because those are the terms that you're going to combine. So when you combine 8x minus 2x, remember that you add or subtract the coefficient only. So 8 minus 2 is 6, and the x is still there. And plus 6 plus 5, we're adding two positive numbers, so we end up with a positive 11. And that is your answer. There's nothing else that you can do at this point. Okay? Like I said, collecting like terms can be very difficult. It can be. It's one of these things, it's kind of like factor or expand. You're going to grasp it really easily, or you're going to work hard at it. And then eventually it'll be second nature, and you'll understand completely what you're doing. Do not be afraid to let me know that you're having trouble with this. Okay? I expect that we might, and so let's make sure we know what we're doing before we just move on. Okay? So with that, I will see you in class.